Kia ora, good evening. Welcome to one more session of Coding Nights New Zealand. And tonight we have a guest speaker, Leandro Carvalho. How are you?
Hey, Marcel, so good to see you again after almost 20 years.
Well, we have a story about this one. So when I was starting my career back, 20 years ago, Leandro was working in one of the learning centers in São Paulo. And I remember like he was taking care of the labs of those of the uh, of the course I was taking. And I mentioned that to him because I never talked to him. And tonight he just realized that he was part of my journey 20 years ago. Yeah, that's very exciting. But I'm really excited about what you're going to present tonight for us. If you could just give us like some sort of overview of what you're bringing to us tonight.
Yeah, definitely. So we're going to talk about how we can put together not only the deployment and development of the solution, but how we can encapsulate testing, automation, chaos engineering, monitoring, health modeling, the high availability into your pipelines. So everything can be deployed, test, scale in a single deployment, and how we can use that to make the applications more secure, more reliable, and always on, or what we call mission critical applications.
I'm very excited like for this presentation. In general, like we have like development sessions, but this one it's in specific like so Leandro is going to be approaching like on how to do like automation Azure DevOps. I think it's an important part for us as developers to understand how to automate the deployments, right, of the different solutions we create, specifically with Azure. And I'm really excited about it. We're going to have like Leandro in a few minutes. Before we jump to that, I'm just going to introduce the user group if you don't know, but we are Code Night user group. We're based in Auckland, New Zealand. In general, we have online sessions, but we are a community group of developers and we love coding and we follow best practices on software development languages and technologies. In general, we focus more on Microsoft stack, but we're open to different technologies. The intent of the user group is to enable developers with practical knowledge to excel and launch their careers. I'd like to mention that we're also parts of Azure Cloud Native group, where we get to talk about what's the latest and greatest on cloud native space. And also we're sponsored by the .NET Foundation, uh, an entity that looks after the different .NET open source projects. I'm excited just to give like the floor for Leandro. Please, I'm gonna just bring like your screen, and yeah, the floor is going to be yours.
Excellent. Thanks for that, Marcel. And I want to make this participatory. So if you have a comment, if you want to if you have a question throughout the presentation, add your comments. Marcel will be looking after the chat for me, so he will be moderating and stopping me to add some of the questions. So here I've got my main monitor and I've got the comments right here. So I'll try to keep an eye on both of them. But I would jump straight into the presentation, if that's okay, Marcel.
Yes, please, the floor is
All
yours.
right. Well, thanks again. For those who don't know me, my name is Leandro Carvalho, and I have been living in Canberra for the last 12 years now. I'm originally from Sao Paulo, and it's a massive city. So Canberra is as small as Wellington. So I love the place. And my background is Azure infrastructure and mission critical deployments. So I work in the support for mission critical team as FMC, and we support pretty much most of the mission critical customers in the region, including some Australian and New Zealand customers as well. Outside of work, I love sports. especially soccer is in the blood. As a Brazilian, we have to. But I also play capoeira, which is a martial art from Brazil as well, that includes dance and music. I'm a teacher, so I love capoeira, a little bit of tennis, ski. I love playing guitar. I'm not sure if you can see at the background my guitars and my favorite albums. And if you want to keep in touch, that's my link to the LinkedIn profile. I have been very active on LinkedIn, trying to add some cool stuff in there. So if you use the keyword code there, it will take you to my LinkedIn page. So with that out of the way, I'll jump straight into the content that we're going to be covering tonight, which is deploying mission critical applications with automation. And we are going to discuss what is mission critical and why mission critical in the first place, how we use the design methodologies from a mission critical perspective to deploy your solution, a little bit of the principles and design areas, and I'm going to be showing you some demos as we go. So at the end, I'm going to share some of the demo code, all the pipelines, all the testing, all the dashboards, everything's part of a GitHub repository. So you will be able to use that as a template so you can start deploying your applications as well. But I wanted to start discussing about mission critical and how that integrates and connects with the whole development lifecycle. As a application that you are deploying in the cloud, not only from a development perspective, you want to make sure that the application is going to be always available, always reliable, and you might have some requirements that might be quite important, such as applications that should not go down, or applications that you might have human lives that depends on it. We do have customers that runs mission critical application where if the application is down, it's not only a financial impact, also the branding impact, but we do have customers in Australia, government agencies, where if the application is down, people can actually die. And that's why mission critical is so important. And that started with the term always on internally, and then it became the mission critical term in Azure. And that only refers to the highly reliable and mission critical nature of all the patterns, the design methodologies, and everything you need to build the solution, give you the requirements, giving you the design decisions, and all the things that you have to have in place for the application to be always operational and available. What I like about this topic is that we're going to develop the application, then we're going to deploy it as part of the DevOps mentality. But we're not only deploying the application, we're deploying operation, we are deploying high availability, we're deploying monitoring as well as security. That means from the development all the way to the deployment, you have the monitoring in there. And what happens normally is that developers deploy the solution and then it gets handed over to operations, and they need to take care of monitoring and automation, scaling, and some other stuff. And in here, I'm going to show you how to put that in a single place where we can do that from the beginning, from the top all the way to the bottom, from architecture, design, all the way to the operations, where the thing will be fully deployed and tested as part of the DevOps process. So what is the guidance for deploying mission critical applications? So there is what we call the design methodology that consists of 3 specific areas. We have the architecture pattern that you can see at the top here. We also have the reference implementations. That's going to be part of my demo. And When you see this kind of architectural references, design references, you go like, well, that makes sense. But how do I picture this? How can I get what you're saying and actually see in production? That sounds beautiful, but I need to see this actually working. And we also have some prescriptive guidance as well as part of that. So at the end of the day, you will have an application or a workload that is optimized and ready to be running on Azure as a mission critical application. All right, so that's some of the topics we're going to be covering here. And the first point that we discuss as part of this design methodology is the SLO, the service level objectives. And as you can see here, this is going to impact your development lifecycle. Depending on what your SLO is, your application might grow or actually get smaller. In my PowerPoint now, you can see the difference from 3 nines to 4 nines and even to 5 nines. And on the right, you can see the difference between them. So this is going to be a business discussion, right, with the architects and the developers. How much would you allow the application to be down for? What is your service level objective so that the application cannot be unavailable for more than maybe 5 minutes a month, 8 minutes a week, or 2 weeks, 2 minutes a week, depending on your requirement. We might need to increase the number of regions we're going to deploy the application to, and also adding some mechanism to make sure that the application is not going to be impacted. And another interesting topic is that the number one impact that we see in this kind of mission critical applications are change management related. The developers might release a change that might break the whole application, and we haven't done the testing, we haven't done the load testing. One simple application in there is like the butterfly effect, which can create a domino effect and bring the whole application down. And that's the kind of issue we are trying to remediate with the mission critical application. So this is the first step. What is your reliability requirements? How much would you tolerate for your application to be unavailable for? And based on that, we can talk about the number of regions, the number of requirements and services, and what have you. And that's going to be quite crucial for the development and the design phase of the application. So let's have a look at, once that's sorted, once you did find out the requirements for the reliability that we just talked about now, we're going to discuss now what are the principles that we need to cover to actually deploy the application. And if you have heard of the well-architected framework, I'm pretty sure you have seen these 5 pillars before. It talks about reliability, making sure that the application is reliable, making sure that the application is scalable and performance is not a problem, so it can cope with stretching and scaling as needed. And we have some mission critical customers that over a weekend during a promotion, they might need to have 30 times the servers they normally operate the environment for. How do I cope with that as part of my development lifecycle? And how do I make sure that when the deployment is done, that is also ready for operations, which is operation readiness. But this is by design, meaning that the operation is part of the development life cycle. It's not a handover. It's not like, there you go, good luck, monitoring, security, automation, backup, scaling is all yours. We are changing that mentality, and that's what DevOps is supposed to be doing, right? Bringing those two together, where developers and people from the infrastructure team, they can actually work together, operations and development. A cloud native design, as well as security are the other pillars. So everything I'm going to show you here have been created based on these 5 design principles that also aligns with this well-architected framework principles. But we need to go deeper than that. We need to give you actually specific details about the application, the database, the security, the networking. So only those 5 design pillars, they are the pillars itself, but you need to give me more insights about how we design the application, how we create the platform to build the application on, how the networking and connectivity should work, and operational procedures. So today I'm going to be talking about some of them. That is going to be, not all of them, by the way, but I'm going to be talking, for instance, about the application design. We're going to be focusing on health modeling, deployment, and testing. But this is only a glimpse of some of the other areas that we have in this methodology. All right. And that's for the architecture and design process. Some of these needs to be taken in consideration, and we give you the insights on design decisions, some recommendations, and also the considerations to help you understand what needs to be done, what needs to be in place, what are some of the recommendations from Microsoft. And it's going to be similar to answering the question, what would Microsoft do if we had someone from Microsoft sitting with us during the design phase of our application, right? And this is kind of the story behind the guidelines, is giving you that insight. What would Microsoft do? What is Microsoft asking you to do to have that dream kind of deployment, right? So the first one, and I think that's one of the most important for you, is the application design. So we are not talking about the development itself, but how we design the application. There are a couple of things that we're going to talk about. The first one is global distribution. So for a highly available application, we need a global distribution in place, as well as what we call scale unit architecture. I'm not sure if the audience is aware of what that means, but in a nutshell, is making sure that the application can be deployed as a single bucket, as a scale unit. And if necessary, we can use that unit to scale the application into different regions, for example. We also have the loose coupled event-driven architecture, as well as the application level resiliency, considering some of the patterns and error handling. So if you go to that link in the PowerPoint, we are going to actually give you some of that design consideration. So let me open that up and show you some of the considerations I'm talking about here. And this is like a workflow, right? Where you start deploying your applications. You start here from the design methodology, which is where I was talking about in my PowerPoint. First thing to consider is the reliability tier, which is the SLO that I covered with you. After we know that, we talk about the design principles, which are the 5 pillars that I also talked about. And then we go through the architecture pattern, which are some of the other considerations that we're going to discuss here, which falls under the design areas. 1, 2, 3, 4, 5, 6, 7, 8 design areas. The first one we are talking about is application design. So, okay, I've got my SLO, 4 nines, let's say, and some of the considerations that I need to get started might not be known to the team yet. We don't even know where to start with. So the first thing we go through here is the application design, where we talk about the scale unit that I described to you right now. So have a look here. We have the worker services, the API services, the compute, which in this example is AKS, other resources, Key Vault, networking, Cosmos DB, and then we give you some design considerations. We tell you some of the things you need to consider, some of the limitations as well for some of them, and we give you the design recommendation. So we tell you, well, make sure that some of the regional deployment stamps um, are ready to go. The subscriptions as a SKU unit might also be recommended. And then we go down to the global distribution with some other parts of the environment as well. All right. So in the PowerPoint, I've got an example to show you here what we mean about global distribution in the SKU unit architecture. So as a global distribution approach, you have services that are spread across globally, right? So here you have, for example, users connecting to Azure Front Door, which is available in more than 130 locations. And Azure Front Door would be receiving your connection and sending the connection to the SKU unit, which in this example is in different regions, right? So have a look. Each one of the 3 points at the bottom here is actually a SKU unit. So I've got one in West Europe, another one in East US, and another one in Southeast Asia. But my front-end services, my database, and my container registry is actually spread across different locations. So I don't have a database in East US or Southeast Asia or West Europe. All of them is using Cosmos DB that have read and write available in all the 3 locations. However, each of the SKU units can be deployed as a single thing. And that's going to be also important for changes that we're going to cover in a second. With the SKU unit, you have some high-level considerations, design considerations, and recommendations from the same documentation that I was showing to you previously. And that's where we add all the requirements, explain to you from a development perspective how you design your application to work on that SKU unit architecture. And that's something that's going to make a lot of sense when we are actually deploying the environment. So let me give you an example here, especially about the deployment with the blue-green deployment. So I'm going to use the pen here. And this is my production environment right now. Because it's actually 4.9, each location supports 100% of the traffic. And the logic behind Azure Front Door is based on the user location, meaning you're going to go to the closest service, to the closest location in this example. So if you are, for example, in Germany, you would get connected to West Europe. Or I can just say, just send the user to the fastest one. Maybe the fastest one for some reason is a different region. So you can work on the routing in Azure Front Door. But now you've got a new version of the application. You are deploying the pipeline to release a new version of the application running on AKS 1.26, for instance, that was just released a couple of days ago. So in that example, when I deploy the application, I can deploy that as another SKU unit, West Europe 2, right? And I deploy the whole thing as a SKU unit. So that's actually a duplication of my production environment with the change in it. Once that's deployed, I'm going to run some tests. Everything is going to be fully automated, including the test and UI tests, smoke tests. I'm going to show you some examples in a second. And once every test has passed, we are going to start the change to send the traffic of 10% to the new region and 90% to the production one. So let's see how that works. So you have 90% and 10%, and then we run a couple of extra tests. If everything is okay, we can switch over to 30%, 70%, and then 50-50, 70-30, 100%, and that's it. You can cut over. If something goes wrong, you can revert back to West Europe. You can leave it running there for a couple of days if necessary. And you might say, look, Leandro, that sounds a bit expensive, isn't it? You're deploying the whole thing in parallel and changing the traffic to that whole deployment. And that's the point with the mission critical. Depending on the criticality, that is more important than the price itself. And also, you have to consider that this is only during the deployment phase. After the deployment is done, you would destroy um, the previous region in that example. But the real reason behind this is that for every change, no matter how small or how big the change is, you're going to go through the same testing, the same stress testing. You're going to do the same load testing, UI testing. That will make sure that you can tick all the boxes that you can as part of the deployment process in the DevOps pipeline to make sure everything's healthy and you won't have any impact in production, right? So that is pretty much the reason behind here, the application, the scale unit approach. Now, talking about after the deployment, health modeling. So to make it a little bit easier for everyone to understand, what I would do here is I will show you my demo, and then we can come back here to health modeling. I've got a couple of things that I wanted to show you. First of all, I actually forgot to open my application, so I'm going to open my Azure front door resource in my global deployment here. I've got a endpoint host name, and that's where my website hopefully will be running. So there you go. This is my website. This is a company that sells some clothing. And if I click on catalog, you can see some of my products. So this is where I can open a catalog icon. I can add some comments, name, comments. I can select some of the products. I can add a rating, and I can also add the product to the cart, right? And if I go back to home, it's just a simple application for the sake of our demo here. Now, let's have a look at my pipeline. So you can actually see how we can convert that image that I showed you into a real pipeline. So this pipeline is actually deploying the global infrastructure, and which is the one that runs across different regions. Front door in Cosmos DB, for instance, this is where all of that gets deployed. And also before that, we test application code. We want to make sure that the code is healthy. Everything looks good. There are no issues there. And we can run that in parallel, by the way. But before we go ahead, the application code testing has to pass, and then we can go and deploy the global infrastructure as well. So after that, we deploy the release unit, and that's when we deploy the whole infrastructure, networking, the services, some of the other Key Vault, for example. And in parallel, we build application code. I don't need the infrastructure. I don't need to do that with the infrastructure. I can just build application code, get everything that I need. And once the application is done, once the application is the infrastructure is fully deployed, I can deploy the workload. So this is happening in parallel. And have a look at the time it took for me to deploy the infrastructure and to build the application code. I did that in parallel, so I'm just saving some time there. Then I deployed the configuration, and after that, everything was good to go. I deployed a workload, right? If we keep going here through the pipeline, we, as part of this demo, we imported some of the sample data, which is the website you saw there. And this is where we started to test the endpoints. So we did a bunch of tests there to make sure everything was okay. And I'm going to show you some of the tests we ran later on. And we also did the redirection of the traffic to the new scale unit. Remember, in my example in the PowerPoint, I mentioned like 10% first, then 50, then 70, and then 100. For this particular demo, we just did a full cut over only after all the tests were complete. We after the whole thing, we tested it again, and we waited for that to run some extra stuff as well. So these are two other things that we did here: the Azure Load Test and Chaos Experiment. Before I talk about those two, as well as the monitoring, I just wanted to show you that this is available as part of a GitHub repository. So this is the GitHub repository that I'm going to provide the link at the end of my presentation. And this is the solution we are actually deploying in this demo. So at the top here, we've got the global infrastructure being deployed. And all of that is, all the code is from the GitHub repository. We are using Azure Pipeline to get the source code and actually deploy the global infrastructure first. Then we deploy the scale units. So I've got one in Australia East, for example, and another one in West Europe. And you can have extra ones as part of your deployment. So this is pretty much some of the things that we have in the GitHub repository. But we actually have everything there. We've got the pipelines, we've got the scripts. So here you will be able to see all the pipelines for the demo, all the testing, the smoke test, the monitoring stuff that I'm going to show you. All of that will be here. The only thing you have to do is update a variable file. Here is a YUM file where you need to create a prefix of your deployment. So here I've created a prefix MCLC01 and which location you want to deploy your solution. I added Australia East only, but there is another deployment where you can add Australia East and maybe 3 other locations. So you can deploy each stamp in in different locations, right? For the sake of my monthly budget at Microsoft, I just deployed in just one place for this demo. But yeah, that is pretty much it. After that, we do have here in the pipeline, sorry, the main page, a step-by-step guide. If we click on getting started, you will see here all the step-by-step to deploy the same application that I just deployed now by creating the pipelines, importing the GitHub repository, giving some authorization, creating the YUM file, running your pipeline, changing some of the, creating the Azure Service Principal to allow the pipeline to run and create stuff in Azure, some of the service connections, and then you change that file that I just showed you, some of the variables in there, and that's it. So once you run the pipeline, you will deploy the whole thing. So this is the pipeline I ran on Friday, last Friday, but I can go ahead and run the whole thing again. Run the chaos testing and the load testing. Let's say I've got a new version of my application, right? It's a version 2.0. And what I'm going to do here, if I click run, it's going to go through the whole deployment process again. It's going to deploy the whole thing in parallel. Then it's going to redirect the traffic, and you can play with the numbers here, like I mentioned in my demo, 20, 40, 60, what have you. And then you can run some other tests later on. So that's the main idea behind the whole thing here. But let me show you a little bit of the testing. Azure Load Testing and Azure Chaos Studio. So I'm going back here. And by the way, if I look at resource groups, you can see here the resource group for my global infrastructure with the stem that I mentioned there, LCMCV1. And you can also see some of the other resource groups, including the stem that I've got running in Australia East, right? So everything that's in my stamp is part of my specific resource group here. So looks like there is a question there from Srini. What if there is a breaking change in the database? I'm assuming there should be no breaking changes. So the database here, Srini, is Cosmos DB. So you have read and write across different locations. Let's say there is a problem within the database in a particular region. You can use the copy in another region. But in your question, for the sake of your question, let's say you deploy this change we are about to deploy right now, change 2.0, right? We are going to deploy that, and there is a bug in the database that we didn't know it was there. We weren't sure that the tests were complete. And anyway, if we go into production, it's going to break the database. Now, let me show you some of the tests we do, and then I think I will answer your question. First of all, let's have a look at Azure Chaos Studio. So I'm opening Chaos Studio here, and I've got some experiments that I have run as part of that deployment. For those who don't know, Azure Chaos Studio is a feature that has been created as part of the chaos engineering methodology that was actually created by Netflix when they were architecting the solution to run streaming, and they wanted to make sure that every change would cater for failures. Exactly what you asked, Srini. So what if the database, there is a change and the database breaks? What if there is something else that might happen in a change that we are not even expecting? The best way to answer that question is to break stuff. Let's just bring chaos into the deployment, and that's why I love this name, to break and see how the application is going to cope. So if we break the application database in this region, would the application fail over to the other region that hasn't been updated yet? Would that be a problem because we are running two different versions? What happens if the CPU of my application is running across 100%? What happens if my networking is down or my key vault is down, right? So if I click here in details, what Chaos did here in this example was to actually inflict chaos into AKS by creating a failure in the AKS part. Now, Srini, just bringing your question back here, we actually break stuff. It's not a simulation. We inflict that chaos into the application, right? So this is something we have to be careful. And that's why we do that as part of the deployment before it goes live. So did you see my pipeline? We did a couple of changes and tests. And before we go live, let's just break. Let's just make sure that we go through the same process, no matter what change is being done. So in here, maybe something will break. We will be able to pick that up in here as part of the test. So in this test, we broke AKS, And we were expecting that the application would still be running in a different region, that Azure Front Door would be able to pick that up from the monitoring that's in place and automatically cut over any traffic from that region and send to the other regions. And or maybe the application has some mechanism that would self-heal itself. But this is how we would be able to pick that up. So that's the first test, breaking stuff. And that's my favorite part. I love breaking stuff. Now, the second one is stressing, which is the Azure Load Testing. Now, this is something that I'm sure the developers will love. Have a look at my load test that I've created as part of this deployment. I ran a test. For those who don't know, Azure Load Testing is going, as the name says, generate a load test for you. But I wanted to show you here the level of testing we are talking about. And by the way, this test failed. And let's have a look why. So these are some of the conditions of my test. I'm going to have a look at the requests per second. And if the average is less than 1200, sorry, it should be okay. If it's less than 1200, sorry, that will be a fail. Here, it was 2500, so it's looking good. Now, if the response time average is greater than 75, then that might be a problem. So in this example here, it went over 75 by a lot, and that's why this application failed. So in my scenario that I gave you, I wouldn't be able to deploy this application because it failed the test. So you can actually add these conditions. If it goes over 1200, it's a fail. If it's below that number, it's a fail. And down here, you can actually see the level of tests we are talking about. We created virtual users connecting to the website. Now, have a look at the description of the test. We added more than 700 new comments. Remember, in my website, I could add comments. We've got random catalog items. So this is actually UI testing. We were clicking on stuff. We added ratings. All of that running at the same time, by the way. We were listing catalog items, and we did an aggregation there. So you can see here when the test went all the way to a simulation of 1,000 users connecting to my website. And down here, you can actually see the results, the requests per second, the average. You can see here the response time as well, which is another one of the other metrics that we have, and the errors. So I've got a lot of errors in here, and my test says that if we have more than a specific amount of errors, that is a fail. So this wouldn't even go in production. As part of the pipeline, you have that in there. So you don't need actually people testing that for you. And again, all of that, all these pipelines, even the testing and the Chaos Studio is in the GitHub repository, so you can actually use it and play with it. The other thing that I wanted to show you that's not here, but I've got some screenshots, is the monitoring part. Not only the testing, but the monitoring. With the monitoring, we take a different approach here, which is using what we call a health modeling. A health modeling uses health status, not the metrics. Take this as a traffic light approach. You have a representation, a diagram representation of your user flow, your services, and then you can see all the dependencies between them. And everything is green. If things go yellow, because you know the dependency, you know where the problem is and what the problem is. Most of the time, you have those nice and shiny dashboards like this one, and you go like, what is going on with the application? If that goes up, is that good or bad? If that's going down, is that good or bad? So that gives you the insight of the metrics, but not the actual health status. When does that actually get bad? When do I need to look at the problem itself? So this is an example of a health model visualization that is deployed as part of that pipeline. So I've got my website here, and at the bottom here, I've got 3 user flow: add comment user flow, list catalog items user flow, and show a static content user flow. That's my first layer, the user flow. In the middle, we have the services providing the user flow, background processor, and the catalog services. And at the bottom, you have the Azure resources itself. You have checkpoint storage, my AKS cluster, my Key Vault, and a public blob storage. Now, by the way, we use here in this example application insight to get the code telemetry as well as Azure Monitor logs in the example. And I think I've got another comment from Aaron saying that I think 3 was referring to breaking changes in a relational database. For example, if we have non-backwards compatible schema changes, like dropping a column. And oh yes, sorry. So it's more a kind of a database, a relational database issue, right? So that
Yeah.
would be
So that could break like the solution, right? So how it would prevent that a release from happening?
yeah. So um, one of the one of the um, design areas is data platform, and here we cover some of those scenarios. I'm not sure here if we talk about specifically on relational databases and some of the changes, but this is giving you all the insights on, what are the downsides, some of the things you have to consider, the speed, variety, the veracity of the application, some of the design recommendations around the volume as well as the velocity. Um, so using some of, I'm not a database specialist, but you have here some specific details that can help you to mitigate some of those examples and help you to understand the risk and what is the best way to mitigate the risk, right? So I would recommend having a look at that particular link there, and hopefully you will have some more insights from a database specifically. So let
We
me
got like
send that
another
to
question.
you.
Not
Yep.
want to interrupt you, but Aaron as well. So he's asking like what you're demonstrating. Are the chaos and load tests run against temporary stamps in production, which have no traffic?
That is correct, Aaron. So we would have, as part of the deployment, when we deploy the stamp in a blue-green deployment, right? So um, the blue deployment is your production environment, and you deploy the green stamp in parallel, but that's only the green deployment, which is not getting any traffic. That's when we break, that's when we run the tests and make sure everything's okay. After all these tests passed, then we can start the switch over. And as part of the switchover, we also have some extra tests as well. So it will only go into production after all the tests have passed. Hopefully, that answered your question, Aaron. And about the repository, I got the link for the repository in the PowerPoint. I'm not covering all the PowerPoints, by the way, but this is the one. We have 2 deployments, by the way, the online reference implementation and the connected reference implementation. The connected use more networking capabilities and some of the different hub and spoke topology, where the online one is the one that I'm showing you. So let me put that in the group chat as well. Just bear with me. I'll ask Marcel to send that to everyone. But yeah, I just wanted to show you an example of my monitoring process here. So have a look at that traffic light example. Sorry, this one. So you have some of the services and you've got some of the baseline. For example, my cluster, if it's running with the CPU of with less than 75%, that's all good. If it's below 90%, that goes to yellow. That's attention. And if it's over 90%, I know that's when we have user impact. So this is how you would see that in a real world scenario. Have a look at the image on the left. In here, the cluster is at 70% auto-scale capacity. So you know that there is an attention level in the cluster that will actually, that could potentially impact all the upstream services. The user flow, add comment, and the list catalog can be impacted if that goes red. So that's when we start looking. We know where to start looking. We know where the problem is, and we know the potential impact beforehand instead of jumping to troubleshooting mode. Have a look at this other example. The background processor queue has more than 100 messages. So that will break my service there, which is also impacting the user flow, add comment user flow in my website. So there is a user impact. This catalog and show static content user flow is okay, but we have a problem right now with the website. That is also deployed by the pipeline, by the way. So you actually have a dashboard using that, which is amazing. And that's what I was talking about, the operation stuff being part of your DevOps pipeline. So it's not up to the operations team to create a dashboard. That is part of the development lifecycle itself, right? And this is the deployment that I just did now. So you've got some global resources, and you can see here each of the resource groups that I showed you in my portal before. There is also monitoring and dashboarding resource groups. And in parallel here, you have some supporting services such as the Chaos Studio, Load Testing, Azure Security Center, and also each stamp has its own deployment. Now, just something quite interesting that I wanted to point out here is that we have the monitoring on each stamp, and we have the monitoring at the global level. The global one is going to monitor, obviously, the global resources as well as the stamp itself, right? If the stamp's down, we want to make sure from a global perspective, we know something's wrong. So even if that monitoring capability is down, you have a backup here of the monitoring in the global layer to monitor that scale unit itself. So it's all about the SLA we were talking about previously, right? If one stamp is down, no worries. We have another one that supports 100% of the traffic. So that is the idea behind it. This is the list of some of the tests we do. By the way, in my demo, in that repository, it wasn't created by me, by the way. It was created by the Mission Critical product group. So these are the legends behind the whole repository. They are actually developers. I'm the infrastructure guy. And if you have some questions, you can post that in the GitHub repository as well. But have a look at the tests. Look at the list. Unit testing, smoke testing, UI testing, which is the one I showed you. And also the load, stress, and performance testing with Locust and Azure Load Testing, the load generation for user simulation, and also the failure injection testing using Chaos Studio. And that's all in that pipeline the code is there. You can copy and change so that it can work in your application. So um, very straightforward. And I guess that we covered some of that stuff already. The only thing I wanted to show you here is the pipeline that I showed you, how the pipeline deploys the whole thing. We first deploy the global infrastructure, then we deploy the release units, the scale units, that is. Then we test the release units. After the test is complete, we redirect the traffic and we remove the old release units. So back to that question from Aaron, all these tests are done before we start redirecting the traffic. So this is the simple pipeline, but have a look at this one, more detailed one. This one, you have more checks and you have like after all the tests are a pass, then add the stamps and start adding the traffic, starting with 10%. Then in the gauge, you have some testing. If it passes, let's do 30%. Then I think there is another gauge. If it passes, 75%. New test. This test, by the way, is not as bad as the load testing in Chaos Studio. It's just UI testing. Make sure that um, user kind of testing, and then we can change the whole traffic, destroy the old stamp, and done. Everything is in production. So that's what gives you the zero downtime updates with the blue green deployment using the DevOps pipeline. But this one I didn't show you in my demo. Have a look at this one. Oops, sorry. My demo, we did 100%. This one did 10, then 50, and then 100 in here. So, which is quite interesting. But that's you can customize that in the code itself. But this is going to give you a very good idea of where to start, what rules you have to follow for a successful mission critical application, and how you can automate and make a full DevOps culture applicable in your infrastructure, in your application by thinking about operations, high availability, the security, monitoring, all of that, testing, breaking stuff, deployment, blue green in a single pipeline. So that's why we've got the links here for the workloads. The one in the middle is the actual GitHub repository, or it has the link for the GitHub repository. The first link is the first one that I showed you with the designs, guidelines, recommendations, and what have you. So if you follow that, you will be successful in deploying the mission critical application that most of our customers are using out there. I do have some more links here for, we have learning paths. There is a workshop, there is a training. I'm actually going to share that one. If you want to go through a training, you can get from zero to hero in mission critical applications in about 5 hours, I think. So the training is really good. I'll put that in the group chat as well. And yeah, so that's what I've got for you today. I just wanted to show you how to use the reference implementation guide to get started. And then, yeah, now it's over to you, pretty much using the GitHub repository as a starting point and start adapting some of the ideas into your deployment. So,
Really cool.
yeah, Marcel, that's pretty much it. We can have some Q&A now if we have any.
Yeah, I think like all of the questions that came up, like you answered. Let's see if like anybody else just bring like other questions. I shared all the links that you shared with me, and I put like on the chat. And I found like this presentation really good, like because well, even if you are not like on a mission critical, you can bring like some elements of the different pillars, right? And bring like into consideration when you are designing your applications. And I found like really interesting that, well, you can pick, like choose, like if you want to bring chaos, well, take the chaos studio. If you want to do like some load testing, I know for sure, like I've been talking like to some like testers. I invited them like to the meeting, and they were like, really keen like to see some examples or how things can be applied, right? So they've seen like a particular store where you just brought like some load testing. I think that probably brought some awareness like to these people. I think like that's a really interesting way of considering how you can make use of the different elements, right?
Hmm.
As you walked us through.
Yeah, that's good. It's pretty much the idea of having the ideal scenario where testing and breaking and monitoring is all part of the development life cycle, which most of the time is the other way around, right? You deploy, you pray to make sure everything's not going to break, and then if everything goes well, you have some other process later to test some of this stuff, but the test is not robust as some of the ones we showed you here with UI tests, smoke tests, Chaos Studio, Chaos load testing, and the pipelines are there. So they are very generic. They are,
Yep.
we use that in a real scenario, that website that I showed you. So people who are familiar with DevOps and some of the code. By the way, we use Terraform to deploy the infrastructure there. So we know that's commonly used by the community, and that will give you a really good starting point to start implementing some of these infrastructures.
I think we got like a last question from Aaron.
Yeah.
So, so do
Thanks
you have?
for the comments there, Aaron. If you don't mind, I will read that out loud.
Yep,
Marcel, do you
do
have
it.
any examples of situations where business wanted higher availability but did not have the resources to achieve it? Costs were too high. Yeah, definitely, Aaron. That's why I told you in the beginning that the first thing we talk about is the SLO. So what is your requirement? How much are you willing to pay to make sure you're going to meet that requirement? Because if you're talking about three nines, it might be only two or three regions, maybe two, and you don't have to have a very large deployment like this one with five nines, right? Five nines, you would have three or more regions, and the more nines, the more expensive it gets, but the customer gets it. They know that um, the more nines means that the more expensive the application is going to be. But at the end of the day, I can't afford to have my application down. We have retail services that have promotions over Black Fridays or the Christmas period, Boxing Day. We have customers running mission critical, healthy health applications where if they go down, people in hostels can get impacted. Educational departments as well, where students might get impacted if they don't have that service up and running. We have infrastructure services. If the services is impacted, people will get stuck in, in traffic, or the train might stop, or the ticketing system might not work. I can't afford that to be down. So with the mission critical, when we talk about the mission critical approach and the idea behind it, they go like, yeah, okay, I get it. Um, so it depends on how much you want to, you're willing to pay when the application is down. And I have seen those examples where customers didn't want to pay that much, Aaron, and something went down, and they were like, okay, we learned the lesson. let's go back to deployment and architecture and let's apply this. It's going to be more expensive, but those 2 hours that we were down last weekend, um, it cost us more than running this for over 3 years with the mission critical approach. So yeah, for me, every application is mission critical. You might need a requirement. You might have a requirement that the application not, needs to be down during available during business hours only, for example, or just over the weekend. But yeah, when you have that discussion about the design methodology and the reliability tiers, people start understanding the impact of the cost in the design of the application.
Yeah. Well, Aaron brought like another question. Maybe the last one to take.
Yeah. Do you manage an environment where deployments happen more frequently than the time that the pipeline takes to execute? Is it possible to run multiple temporary stamps to verify deployments? So what we do sometimes, Aaron, is we split the stamp into logical stamps, and that means infrastructure and application. So most of the changes are application, right? You don't have to deploy the whole infrastructure all the time. So we have seen customers doing that whole pipeline, and when they deploy the test, they break the application only. Obviously, you are missing some of the tests across the whole infrastructure, which could be a problem. But because the changes in infrastructure is not that often, you can actually break that down, um, and make those changes in different logical steps. But so far, we haven't seen customers that change. Well, the customers that have faced those challenges, they broke down infrastructure versus the application pipelines.
Cool. I think like those were the last questions. I'd like to thank you, Leandro, for the presentation. Was great. Just to have like that sort of discussion and the awareness that brought like to the developers and who joined the session. Um, this session is going to be recorded, available on YouTube. So if you want like to verify and check like the details, you can always review it on the channel, YouTube channel. Um, Not sure if you have like any other words, Leandro, before like we finish.
No, that's I just left my link there in the PowerPoint in case people wants to connect on LinkedIn. And yeah, we can keep in touch there. And I'm always posting about mission critical stuff. So yeah, that's it. I just wanted to thank you, Marcel, for the invite, and I appreciate that.
No, thank you, Leandro, for making the time. And we're gonna have like other sessions coming in this month, by the end of this month. I invite you guys just to check the meetup user the user group and see the details. We're gonna have like sessions coming around developments, and also the global Azure is coming, and we're gonna have like great sessions here in Auckland. It's still not announced, but I'm just saying that's happening, and just watch on the meetup, and we're gonna bring like some news as soon as they come and we can announce officially. So yeah, thank you. Have a good evening, a great evening, and we talk to you guys soon, the next session. See you later.
Bye.